My topic for seminar is Cermet, and through this session I hope I will give a clear understanding about Cermets. These are the topics to be discussed. First of all, let us see what is Cermets. Cermets are powder metallurgy components widely used in machining application. Cermets are composite materials composed of metals as well as ceramics. The usage of Cermets can be traced back to the time of Second World War. Cermets were developed in 1930s by two German scientists, Skwarzow and Herschel. Cermets basically consist of carbides, nitrides and carbonitrates with binders like cobalt and nickel. But during its initial development stage, it had a disadvantage of high inherent brittleness. So after development, the scientists found out that the usage of titanium and tungsten can help to overcome the disadvantage of high inherent brittleness. The present generation of Cermets contain titanium, tungsten and carbon with cobalt as the binders. The Cermets have a ceramic skeleton binded together by using a metallic binder. The ceramic have the benefit of metal like toughness and impact strength combined with the benefit of ceramic like hardness, oxidation and heat resistance. The structure of Cermet contains a titanium carbide or titanium carbonitrate core which is surrounded by a rim, and this rim is formed during the sintering process. The cores are binded together by using a binder. Cermets can be classified into three: carbide-based Cermets, oxide-based Cermets, boride or nitride-based Cermets. The oxide-based Cermets, as its name suggests, will have an oxide-based material combined with another material. And the combinations can range from alumina bonded with chromium and tungsten, or alumina titanium with chromium and molybdenum, and so on. The main usage of this oxide-based Cermet is that they can be used as a fuel for nuclear reactor. The carbide-based Cermets have a carbide-based material combined with another material, and the combinations can include tungsten carbide with cobalt or titanium carbide with cobalt. The application of carbide-based Cermets is in the manufacture of cutting tools as well as wear resistance material. Boride and nitride-based Cermets boride and nitride-based Cermets have a boride or nitride-based material combined with another material, and the combinations can include zirconium diboride with silicon carbide or titanium nitride. They have an advantage of giving high corrosion resistance in high temperature. The important characteristics of Cermets is that they have low friction, minimum tendency to stick to the workpiece so that the material wastage is avoided, low thermal conductivity, high heat resistance, high performance tool, and as we have said, high resistance to corrosion in high temperature. Production of Cermets can be easily understood by using this schematic diagram. First of all, the raw material will be ball milled, and the product after ball milling will be dried. And if we have a particular requirement for shape and size, the product will be compacted as well as screened. After compacting and screened, we will be conducting pre-sintering in 450 degrees Celsius and sintering in 2000 degrees Celsius. If we are using the Cermet for the production of cutting tools, we may need to coat them. So in order for coating, we are using chemical vapor deposition process and alumina or titanium carbonitride for coating purposes. And after coating, we will get our required product Cermet. There are four important Cermet grades. The first one is high-speed cutting and finishing operation. It has tungsten carbide 16%, carbides in 10%, binder in 8%, and the balance is titanium. Each four grade of Cermet exhibits good heat and wear resistance. The importance of the first grade is that it has got excellent resistance to oxidation. The second grade is high-speed cutting and all-purpose grade. It has tungsten carbide in 15%, carbide in 10%, binder in 12%, and the balance is titanium. The importance of this grade is that it has got good toughness. The third grade is high-speed cutting and rotary operations. Unlike the other two grades, in this grade we does not use tungsten. So instead of tungsten carbide, we will be using molybdenum dicarbide in 10%, carbide in 12%, binder in 15%, and balance is titanium. This grade has got good toughness. The fourth grade is coated Cermets, and it has tungsten carbide in 15%, carbide in 10%, binder in 12%, and the balance is titanium. The coating on this grade is given by chemical vapor deposition, and the coating will be of alumina or multi-layer of coating of titanium nitride. The most important property of this grade is that it has got good oxidation and crater resistance. The advantage of Cermets include optimum surface finish, close tolerances, longer tool life, dry machining, or no need for subsequent drying or finishing. The application of Cermets include: Cermets can be used for the manufacture of cutting tools. Cermets can be used as the fuel for nuclear reactor. Cermets are used in electronic industry for the production of resistor, capacitor, or high temperature application devices. And this is the reference I used. Thank you.